Hello and welcome to Section 7 of the Silviculture Distance Education Module, How Forests Grow and Develop. My name is Paul Esther and I'm going to be your instructor for this section. Forests are dynamic systems, and as such they are constantly changing through time. Understanding how forests grow and develop is going to be one of the key cornerstones to helping you manage your forests so that they will meet your goals and objectives. In the last session we talked about forest ecology. One of the important things we covered was tree tolerances to environmental factors, things like shade, moisture, and temperature. This background is key to understanding how forests grow and develop. This section is important because it looks at how an established stand of trees grows up and develops through time. Once you understand these dynamics, you can use this knowledge to figure out how to influence forest changes to meet your goals. In this section, we're going to discuss what resources trees need to grow, the stages of stand development, and finally crown differentiation and what this means from a growth and stand development perspective. There are two ecological facts of nature you should know about when managing forest stands. The first ecological fact is that the amount of resources available to trees, and other plants for that matter, on a given site is fixed and cannot be increased, except through artificial means like irrigation and fertilization. But for this discussion, we'll not consider methods of boosting site productivity. Site resources include sunlight, water, nutrients, and space. Collectively, these resources represent the total amount of growing space available to trees. This could also be thought of as a bucket of resources available to trees for a particular site. For example, sites on good soils with high rainfall are going to have a bigger bucket of resources than a site with shallow soils or low rainfall. Thinning allocates the sunlight, water, and nutrients to fewer desired trees. So the bucket of resources, that is the growing space, although the same, is now allocated to fewer trees. The second ecological fact is that the amount of resources required for tree growth are proportional to its size. This means that big trees need more growing space, that is the water, nutrients, light, and space, than small trees. Given the two ecological facts just mentioned, the amount of resources used by all the small trees in this picture may be equal to the one big one. This leads to another ecological fact. You can only have so many trees of a given size on a site at any point in time. So how can we grow many small trees into fewer large trees when site resources are limited? To answer this question, let's take a look at the process of stand development. For even-age, single-species stands, there are typically 5 stages of development. If you can recognize these stages and understand their implications for how a forest is growing, this information can help you predict how your forest is going to respond to management. The first stage is a seedling stage. And let's assume that this site was carefully planted with one species of trees, and all the seed came from the same seed zone, and all the trees pretty much had an equal opportunity to grow and thrive. In the seedling stage, individual trees are growing at a maximum rate because there's no direct tree-to-tree competition. They have all the resources they need. At this stage, the trees are small and not able to make full use of all the available site resources. On a per acre basis, tree volume growth is very slow, even though the rate of individual tree growth is high. If we leap forward in time a few years, the forest enters the second stage, called the crown closure stage. Here the trees are larger and their crowns begin to touch. At this point the trees are beginning to compete with each other for the site resources. As the trees shade each other, the crowns begin to lift, which means that the lower branches are not getting enough sunlight and they begin to die, thus lifting the crown above the forest floor. Although the trees at this stage are beginning to compete with each other, site resources are still not fully utilized. Stand volume growth is going to be slow, but it is increasing as trees increase in size. Okay, let's move forward a few more years. Now we see that something very interesting is beginning to happen. Recall that all these trees are the same species. They were planted on the same day and theoretically pretty much all had the same opportunity to succeed and to grow well. But in stage 3, which we call the crown differentiation stage, notice that some trees are large and robust while others are smaller in height and diameter and not doing very well. Individual genetic variation, microsite differences, and other factors somehow combine in a way that allows some trees to grow faster than their neighbors, and they begin to dominate the other trees. As this happens, the dominant trees become the tallest and biggest trees in the stand, while the others progressively fall further and further behind. At the crown differentiation stage, the competition for site resources is quite high, and individual tree growth, diameter growth, is slowing. However, at a stand level, volume growth is at or near maximum, and crown lift is very noticeable. Being able to recognize trees of various crown classes is going to be important for selecting which trees you want to keep and which ones you might want to remove when thinning your stand. I'd like to talk a little bit about the characteristics we look for when identifying the various crown classes, and I'm going to start with dominant trees. These trees have large crowns that extend well above the general level of the canopy and receive full sunlight from above and sun from the sides. The sides of the crowns are going to be well developed, but they can be crowded by other trees. Because their crowns are large, dominant trees have plenty of photosynthetic capacity, which gives them a good growth rate. Another group are called codominant trees. These trees have medium-sized crowns that form the main canopy, and although they too receive full sunlight from above, they get very little from the sides, so their growth is generally good, but not quite as good as the dominants. Intermediate trees are shorter than the dominant and codominant trees, so that they have small crowns with intense crowding on all sides. Their crowns do extend into the main canopy, but they receive little direct light from above and none from the sides, resulting in poor growth rates. And finally, suppressed trees are trees in the stand where the crowns are completely overtopped by the bigger trees, and suppressed trees receive little or no direct light from above or from the sides, and their small crowns result in extremely poor growth rates. As we travel further into the future, the competition between trees becomes so severe and intense that some of the weaker suppressed trees begin to die and the self-thinning stage begins. As these suppressed trees die, it frees up additional resources for the remaining trees, and the dominant and codominant trees continue to grow well. Intermediate trees will continue to fall behind and become suppressed, and they too will eventually die as the dominant and codominant trees outcompete them. Individual tree diameter growth continues to decline, but on a per acre basis, the stand growth reaches its maximum at this stage and begins to level off. Eventually, the stand enters the mature stage. As the stand continues to age and as the intermediate and suppressed trees and sometimes larger trees begin to die, gaps are created in the canopy where the crowns used to be. Sunlight can now reach the forest floor, allowing brush and shade-tolerant trees to begin growing in the openings. This is the precursor to old growth conditions and is the result of many decades of tree-to-tree competition. Stand development can take a number of different directions and can vary quite a bit from what we've shown in the past few slides. Some of the factors that influence stand development include whether you plant seedlings or rely on natural regeneration. There's competition from other vegetation. How far apart you space your trees. The genetic growth potential of individual trees. If there are multiple tree species or single species in the stand. If there are variations in site productivity. And past disturbances from fire, wind, logging, and insects and diseases. These factors can shape and influence stand development and can result in a myriad of growth and forest development patterns. C. Substantial changes in tree position, tree size, and stand density will occur as stands develop through time. In addition to the stages of stand development, other changes in forest structure and species composition can occur, such as succession, which was discussed in the forest ecology section. In many of our forests, the natural fire cycles have been interrupted for many years as a result of our fire suppression policies. As a result, shade-tolerant species, as you see here coming up under this ponderosa pine stand, that previously were killed out by fire have been able to seed in under the bigger trees and grow up into the canopy. The shade-intolerant species, like the ponderosa pine in this photo, don't regenerate well in shade, and as a result, the stand slowly will become dominated by the shade-tolerant species. And so you might ask, so what? Well, this forest condition has long-term forest health, wildfire, and wildlife habitat consequences. For example, some of our more aggressive and damaging defoliating insects cause more damage to stands dominated by multi-aged, shade-tolerant fir species. And these multi-layered forests are more prone to hot, stand-replacing crown fires. This is primarily a function of an increase in ladder fuels, which are those small and medium-sized trees creating a link between the forest floor and the upper canopy. The changing stand structure is going to favor some wildlife species over others. As a forest manager, you will have to consider whether this meets your goals and objectives or not. Once you understand and recognize the different stages of stand development, such as seedling, crown closure, crown differentiation, self-thinning, mature, and stand replacement, you can use this knowledge to provide valuable insights into how you can manage your forest to achieve your objectives. And I'll use several examples to show you how this works. So let's go back to the seedling stage. As we discussed, a fully stocked stand of seedlings will not be able to use all the site resources because the trees are so small, and that's okay. As a forest management, the two questions at this stage are going to be, is in fact the site fully occupied? Or do you need to fill in places with additional trees? And are the seedlings free to grow, or is their growth going to be compromised by competition from grass and shrubs? Early competition from grasses, forbs, and shrubs can greatly reduce the tree's growth and survival. So this is an important issue which we're going to cover in more detail in the forest regeneration module. As the crowns begin to close in, you may want to consider thinning the stand in order to maintain a high level of growth. This will allow for maximum individual tree growth and reduce the time to the first commercial thinning. In small tree diameter stands, there probably won't be an opportunity to harvest merchantable products to help pay for this thinning, so this kind of treatment is called a pre-commercial thinning, or PCT. A PCT costs money, but it may be necessary to achieve your goals, and cost share money may be available to help offset some of these costs. PCT and other kinds of thinnings are going to be discussed in Section 9. Or you may want to consider waiting and doing a commercial thinning later. This normally occurs when a stand is not too dense and can grow reasonably well until a commercial thinning can occur, or if stands are close to commercial thinning size, like an 8-inch DBH. When a stand reaches the self-thinning stage, trees are beginning to die from competition stress, and this is a warning sign forest managers should pay attention to, especially in eastern and southern Oregon. It might be okay if the suppressed trees die, but you should look at the rest of the trees as well. In very dense stands, even the dominant and codominant trees may be suffering from competition stress, which can make them susceptible to attack from critters like bark beetles or other damaging agents. And the trees that Mother Nature decides to kill may or may not be the trees you want to get rid of. So to be in the driver's seat, proactive management can be a necessity. A mature stand may present you with a number of management options. A given stand may possibly be managed for any number of possible outcomes, so it will be important to have your goals and objectives clearly defined. If stand density is high, a commercial thinning can provide income while maintaining a healthy and vigorous forest. The stand could be thinned to create or maintain a uniform, even-aged, even-sized kind of structure. Or it could be thinned in such a way to promote a high degree of crown class diversity. Or it may be time to think about getting ready to establish a whole new forest, and there are a variety of ways to accomplish that depending on your interest and what you have to work with. These options will be discussed in more detail in the silvicultural systems and thinning methods sections. When shade-tolerant species begin to exert dominance in a stand that had been mostly shade-intolerant trees, the situation offers both challenges and opportunities. The road you choose depends on your objectives and what's going on in the forest, such as its condition. If your preference is to maintain the site in shade-intolerant species, like the pines in this picture, then it'll take some work to get rid of the invaders. This likely will involve a thinning from below, which we'll cover in the silviculture systems section. But let's suppose the overstory of shade-intolerant trees is heavily infected with mistletoe. If the regenerating new trees are of the same species, they will be susceptible to infection, perpetuating the problem. However, because mistletoes are tree species specific, the new shade-tolerant trees will be immune to the mistletoe and are an option to consider, in this case, as the new forest. Or you can go ahead and thin to manage stand density, but leave representatives of all species to increase species and crown class diversity. If one of your goals is managing for wildlife, this improved diversity will have some real benefits. If your stand is overly dense, contains a large amount of dead trees and down dead material, you may be facing the very real possibility of experiencing a stand replacing event, such as a severe insect outbreak, a wildfire, or maybe both. It may be high time to reduce stand densities and fuel loads to prevent the likelihood of such a catastrophic event. So how do we figure out how our trees are doing? Are they growing vigorously or barely hanging on? Did the trees left in the thinning respond? You can tell a great deal about the condition of your forest just with a visual examination. The density and crown class distributions are pretty strong clues as to what's going on. But more precise information can be more valuable, and it's not hard to obtain. One tool many forest managers use is an increment borer. The increment borer can help you find out how your trees are growing. It's a precision instrument that allows you to drill into the bole of the tree, then extract a small core of wood that shows the annual rings. The annual rings can tell you how well the tree is growing now, what its growth history has been, and if you can count all the rings to the core, you can get an age to the height where the core was taken on the bole. By sampling a number of trees, you can get a good idea if the stand is growing well or if it's having some problems. This shows how the core is extracted from the increment borer. The illustration shows a spring or light-colored wood and summer or dark-colored wood. The combination is 1 year of bole growth. You can see from this picture that during the last 5 years, tree growth has slowed, which indicates that this stand is getting crowded and should be thinned. Knowing how your trees are growing has many benefits. If you thin and leave your best trees, growth rates are going to be good, and so will vigor. If tree growth is slow, your trees are at higher risk of being attacked by pests or dying from competition-induced mortality. Either can disrupt your management goals. Trees live a long time and forests develop slowly compared to human lifespans. But it's important to always remember that forests are dynamic systems. They are always changing. It's up to you to determine whether or not the trajectory of that change will lead towards realizing your goals and objectives. By understanding how trees grow and develop through time, you can use that information to help you decide on appropriate management actions. For example, leaving dominant and codominant trees will lead to faster individual tree growth, allowing you to thin at shorter intervals as opposed to leaving slower growing, intermediate, or suppressed trees. The best trees will also be healthier and less at risk for pest-related mortality. In Section 8, we'll introduce the concept of managing stand density or stocking. There are biological limits on how many trees will grow well on a particular site. It's important to recognize these limits and understand how to use density management concepts to keep your forest healthy and vigorous.